everybody. Welcome to the last demo day of 2025 for KP Ready Co. We have a jam-packed day of different technology platforms across the building lifecycle. And so we've got 6 presenters today. We'll do about 10 minutes each. And then any questions you have on each of the different platforms that's being presented today, feel free to drop any questions you have in the Q&A section. And we'll go ahead and get those answered after each presenter is ready or is finished with their product. We just had our successful Vibathon and AEC Summit this week in Phoenix, Arizona. It was great to see everybody out there, and the engagement was incredible. We will be announcing some things on our Q1 event for 2026 on January 13th. That will be in San Francisco, California. So keep an eye out for announcements on that, as well as our other quarterly events that will be coming up for the 2026 year. So to get things kicked off, we're going to start with Adam from OrthoGraph. Adam, if you want to go ahead and take the screen.
Okay, thank you, David. I hope I took the screen now by just simply talking, because I'm switching between different cameras. So OrthoGraph is a digital twin solution focusing on industrial and facility operations. We created a technology that can be used to capture any existing building into a BIM model. We call it operational BIM, and not just speaking about the floor plans, layouts, but also speaking about the graphical asset inventory within these buildings. For this, we use very simple and drag tools like laser distance meters or an iPad or this watch-like thing, which is an RFID reader, to provide an accurate, appropriate asset inventory within the system. Now let's focus on the industrial world, so industrial maintenance with operational BIM. So what are the major clientele who are struggling of not having the appropriate operational data in their facilities? Typically, we focus on factories, server farms, utilities, but any kind of corporate real estate or hospital, any kind of facility can benefit from having such valid, up-to-date information about their current layouts and the inventory within them. The major problems of these, or the most critical problems of these facilities, are typically the unplanned downtimes, which cost typically from $100,000 per hour to up to $1 or $2 million per hour, depending on what kind of industrial facility it is. And the major goal is to prevent these downtimes. In addition to this, most of the building knowledge, including also the assets, also the object knowledge, so the machinery knowledge, is stored only in the heads of the maintenance crew. And this knowledge can be very easily lost when the maintenance crew or some part of it leaves for any reason the company. The third problem that we meet is always that the factories, and also this is true for any kind of facilities, there are always changing in these factories. New production lines are installed, or tenants are coming and going, or functional changes are in these buildings. And this is what we are focusing on with operational BIM. The 3 main pillars of operational BIM is, first, it should be very easy, and it is very easy to capture any existing building with their graphical asset inventory into this digital twin. Then we can give access to this kind of data on site using a mobile device for the maintenance crew, just to simplify the navigation to the maintenance points, to get access to all knowledge about the given machinery. And also at the same time for decision makers, providing a web access, a graphical web access to this same data, which means that any kind of decision makers can easily run graphical reports in the system. At the same time, when we speak about digital integration or digital accessibility, then we also provide an API, an application programming interface, through which any kind of external systems can access our own system to gather out the building data, the asset data, the inventory, anything that is needed for their purposes. And probably the most valuable differentiator, what we do and no other does on the market, is that any change that happens on site can be recorded instantly where and when it happens by the maintenance crew. So there is no need for architects, there is no need to use CAD systems to keep the BIM, so the digital twin, updated, but the maintenance people can update it when and where these changes happen. Now let me show a little bit how it looks like on an iPad. So this is my iPad, and this is a cooling plant of a brewery. This, what you see here, have been captured in 3 weeks by one surveyor. And all the elements here, what you see, have lots of knowledge stored together with them, including QR codes, parametric data of the machinery, or also we capture panoramic photos like you can see here. So this is how it looked like when we capture this. And also thermal images or any kind of photos can be stored together with this data. And as I mentioned, the most or biggest value is that we can change the data without a problem. So if I say that this should be a 3 meter wide compressor from now on, then this is how you could change it. Or if it's said that, okay, we moved it around in the building, so then let's move this compressor to a new location, then it's that easy. And obviously anything that we change is instantly reflected in the 3D model and also instantly can be merged up to the cloud when and where there is an internet connection. We also extended the system while it's a BIM system, so we have a graphical knowledge of the building. We also extended it with a workflow control solution, which is an AI-based maintenance management solution. We call it OrthoGraph AI maintenance. So that if we open up the same model and we say, okay, I would like to speak to this machine or talk to this machine, then I instantly see that there are already open or closed work orders. And I see that there's a problem, then I can give it a like that, okay, so it's still there. Or I can open up the conversation with the machine and I can ask the machine about its current state. Or I can say that there is a leakage in the machine. And then the machine will instantly respond based on its knowledge that based on the maintenance history, it happens 3 times or 5 times in the last 3 months. But based on the documentation, it's not normal. And then the system can be asked, okay, then how did we do it? How did we repair it? So it means that the AI is continuously learning the system, learning how we operate the buildings, and give better and better hints how to maintain, how to repair these problems. In addition to this, we can also attach documentations to all the machines, their maintenance manuals, their users manuals, etc. And then these manuals are also handed over to the AI for processing. So we can ask about that, okay, show me the attached documentation. Also, these documentations can be accessed using a simple web browser. If you wish, then you can even scan this QR code. I will show it also later, just to try it out on your mobile devices. Because, as I mentioned, the first and most important, or one of the most important benefits of our system is the simplicity to use it. So by using a simple phone, anyone can access the system and anyone can start talking to the machines or can start reporting a breakdown and can get access to the 3D model as well. So what we have seen here, so we speak about data, we speak about up-to-date building information for the operations. And I think this is the highest value proposition. So what we can achieve is that we can minimize or prevent these downtimes, what I mentioned cost sometimes millions of dollars per hour, not per day or week. We can also become independent from the suppliers or employees of the company because all the knowledge goes into a central single source of truth, serving all the operational activities. It's also a self-educating system using the AI, so it learns from how we operate the buildings. And obviously, it's an AI-based system, the usage of the system can be kicked off instantly, so without any long initial deployment periods. So this is about OrthoGraph. We bring valid data, up-to-date valid data for the operation in all kinds of these industrial segments. Thank you for your interest.
Very nice, Adam. So we have a couple of questions from the audience. First one, do you do LiDAR scans of existing facilities? Or maybe explain more, how do you get the as-built condition and what are the options in order to produce that?
We use laser distance meters like this one. So we don't use LiDAR technology, or we don't use laser scanning technology because we built up our technology that it can be used by high school students or university students. So to make it easy to do the capturing of existing buildings. And these technologies, both LiDAR scanning or both laser scanning, requires technology which is very expensive and typically sensitive. So you would not give these items, this equipment into the hands of the students on one hand. On the other hand, these machinery, so these laser distance meters are much more accurate than the LiDAR technology. So therefore, we use these simple and drag tools to capture these buildings.
So how difficult is it to capture all existing conditions? Are you having to measure every little component?
Think about that I mentioned that high school students or university students are typically hired for these jobs. So it's really easy to learn it. It takes a 3-day long course. We have a course dedicated for teaching people how to use the technology to capture large buildings and also including their inventories. And after these 3 days, of course, the surveyors can achieve approximately somewhere between 20,000 to 10 to 20,000 square feet a day nothing to beam capture on site. And as we have a teamwork functionality, you can employ more people doing the same thing. The tools we use are not expensive, so it means that it's really easy to scale the team to capture these buildings very rapidly. As I mentioned to you, this factory that I showed you took three weeks to capture. So this is the one that I'm speaking about. This took 3 weeks to capture by one surveyor. And all the pipes, all the machinery have their data and have their details. And it also includes the photos in them. Okay?
Very good. Another question. Can we have just floor plans and specifications with QR codes? In large projects, BIM is not filled with a lot of information. Basically, can we pin a task on a floor plan and give it to the facilities managers?
Actually, OrthoGraph is made to capture these buildings, but if you wish to rely on the existing floor plans, then there are two ways. If these floor plans are available in IFC format, so they are BIM files that they can be imported into the system. If they are floor plans made in PDF files or simply scanned blueprints, then these can be put in the backgrounds of these layouts, and then you can place the machinery on these items and then start doing the graphical asset inventory. So it means that any kind of source can be used to start working on the system, but being the surveying so easy and so fast, maybe it's better to think about maybe to capture the existing buildings at last, let's say the last time in their life, because from that moment they can be kept updated by the maintenance crew.
Another question. Do field updates on software updates update all line work in the model, such as piping, HVAC, etc.? If so, is there clash detection?
No, it's not a designing application. So we are not a CAD system. It's not made for designing. We are made for capturing the existing situation. So if something was rebuilt, modified, I mean, designed in the CAD system, then rebuilt and modified, then our system should be used to capture the as-built situation of the final result. And then clash detection, it doesn't make any sense because if it could be built, then there is no clash actually.
So, and if you upload a floor plan, say you have your base design and then you go check dimensions, it's easy to make those updates in your system from
Easy to make
plan.
those updates, but much faster to capture, I can tell you. So we can import these IFC files, as I mentioned to you, then we will have walls, doors, windows, everything placed in a 3D model. But when you start measuring the real life situation, and there are deviations, and there are always deviations. Let's say what we experience somewhere 8 to 15% comparing the real life and the digital twin, then these differences will add to each other. But when you start surveying a building using OrthoGraph, then all the measurement inaccuracies and the as-built inaccuracies will be very easily and very nicely hidden into the walls themselves. So it will result in a much easier maintainable model than if you start from importing an existing file. But it's not a question of OrthoGraph, actually, it's a question of mathematics, how it happens.
Great. Well, no more questions, but post your contact information in the chat so people know who to reach out to get
Thank you very
more,
much. And
get
I'm
their
more than
hands
happy
on.
to provide live demos as well. So if someone is curious about how to do it, then I'm more than happy to show it live. Okay. Thank you very much for the opportunity.
Very good. Well, thank you, Adam. Demo day of 2025. I appreciate everybody joining. As a reminder, we'll be announcing our Q1 event on January 13th in San Francisco coming up. So it'd be great to have you out there. If you're not following us or everybody on this panel, please go do so at LinkedIn to stay up to date with where these technologies are evolving to. Any other questions, or if you have any questions about demo days in the future, feel free to reach out to me directly and I'll be happy to answer anything you have. So with that, we'll wrap up 2025 with this fantastic panel of presenters. And I look forward to seeing everybody in 2026 when we'll restart our demo days on the last Friday of each month at 12 p.m. Eastern Time. So thanks again to our panelists, and thank you to the audience for watching all this cool stuff that's coming out into our industry.